So, again, tonight is Greenback night from 6 to 8. Bring your parents. It'll be a good way for them to see your classes and for us to get to know them. That's what we want to do. Now, does everyone see the new word counterexample? Counterexample is a what? An example that proves what? A statement false. Very good. So, if I said, if it's Monday, then you have to go to school, is that true? For every Monday. Okay, so it's not true for every Monday. So instead of just saying no or false, now I want you to give me a counterexample. Which Monday do you not have to come to school? Which one? Martin Luther King Jr. Day, right? What's another one? Just happened. Labor Day, Memorial Day, summer days, spring break day, Monday, Thanksgiving Monday. Okay, yes. So any holiday Monday, obviously you're not going to come to school. So that was a verbal example. Now here's the one you got to do on your warm-up. You're going to do this. I'm not going to do it for you. It says, if a number is positive, then it is even. Is that true? Are all positive numbers even? Okay, so you can write false, that's fine, but then you need to give me the example. Give me a specific example that proves that false. 37 is a positive number that is not even. So 37 is a good counterexample. Good job. What's another counterexample? Even numbers are 2, 4, 6, 8, 10. Right? What else? What's another example that proves this false? Now, negative wouldn't be a positive. It has to be a positive number that makes this wrong. What else? 25 is a positive that it's not even. Good. What else? 1. Okay. So any odd number. So has everyone written down a counterexample on your warm-up? You have to put your own, right? I'm not writing it for you. But I just said it. Were you not listening? Well, what number did I just say? No, he was. He was. He told me. So yeah, you could write 1, you could write whatever, but you have to write something. Okay? So again, I would like you to write this, and then put false, and then give me the counterexample. Okay? So write, if a number is positive, then it is even. False, and then give me a number. That number is the counterexample. Okay? Do that now, and I'm going to pass out the notes for today. We got a lot to do today, and I don't want y'all to ask me to go to the restroom in the middle of this when it's like really important. Okay? So I guess get ready. And you can already get ready by taking out the headphones in your ears for reals, because again, it's only super important for both ears because this is brand new stuff. So there you go. All right. Can I listen to music? Sure. Let me see. Oh, yeah. Couldn't tell, you know? Sometimes it's hard to tell. Who else? All right, I do need the headphone out. Please. So we are at this page. Okay. Now, we already did this. We kind of already went over the first part, counterexample. So you can go ahead and write this down. A counterexample is an example that proves a statement is false. Go ahead and write that down, please, at the top of your notes. Everyone have it? Okay. Now, these next 3 are like the warm-up, except you're going to tell me, is it true or false? If it's false, then you write the counterexample, okay? On number 1, it says, if a figure is a square, then it has 4 sides. Is that always true? Can you think of a square that does not have 4 sides? Exactly. All squares have 4 sides, right? So is that true or false? True. Okay, write it down. Sure. You can put T. Okay. True. Now, number 2 is asking it backwards. If a figure has 4 sides, then it is a square. Is that always true? So now, counterexample. What's an example of a 4-sided figure, not a square? Not a triangle, because it has 4 sides. Rectangle. What else? Trapezoid. Kite. Rhombus. Diamond. Parallelogram. So we're going to put true or false. False, and then you can write your counterexample. If you don't want to put rectangle, put something else that's 4-sided that's not a square. Okay? Cool. Now, next one. If 2 different lines intersect, then they intersect at 1 point. Now, can you think of a line that intersects at more than 1 point? Straight lines only cross once, right? The only time they cross more than once is if they're literally the same, then they're always touching, right? What? I'm trying to show you. All right, well, anyways. So, but if they're different lines, they only intersect 1 time. So that is actually true. Cool? Okay. Down here, a conditional statement, right? Now, we talked about this yesterday with the magazine thing. Conditional is an if-then statement. The statement that can be expressed in if-then format. So if you're the Cowboys, then you beat the Redskins. It's facts, you know? Big facts. What'd you say? No. All right, so, okay, so that's conditional, but I think it's false. So, all right. Actually, if you're the Cowboys, then you're going to the Super Bowl, and I will cry tears of joy. All right, so next one. If blank of the statement, now, if blank, then blank. The first part we call the hypothesis. Y'all seen that word before, hypothesis, in science? It's always at the beginning. So just like in science, okay, a conditional, the hypothesis is the first part. So if I say, if I'm Mr. G, then I'm cool, the hypothesis is if I'm Mr. G. That's the beginning, okay? True. Now, the next part, if you start with the hypothesis, what do you end with? Does everyone write this down with the phone over by the window, right? So, what do you think the last part's called? Put it away. You start with a hypothesis, you end with a conclusion, all right? Write that down. And it's off to the side here, by the way. But anyway. So we have a hypothesis at the beginning, conclusion at the end. Now, instead of having to say hypothesis and conclusion every time, we're going to abbreviate these with letters. So you can see that off to the side here. P is going to stand for my hypothesis. Okay? We're not supposed to have headphones, please. So, P is the hypothesis, and then Q is the conclusion. Now you tell me, how can I remember that the hypothesis is P? What? It has a P. So the hypothesis has a P in it, right? And then conclusion has a, well, okay, conclusion doesn't have a Q, does it? But you can make it sound like it. The conclusion sounds like it has a Q in it, right? All right. So hypothesis is P. Conclusion is Q. All right. Everyone remember that from now on, forever, right? Okay, now, here's the dealio. If you have a sentence, they want you to be able to tell me what is the hypothesis and what is the conclusion. Is everyone looking up here? So, here's how you do this. You're going to underline the hypothesis and you're going to circle the conclusion. Okay? Now, the hypothesis is always after the word if, right? That's what it said up here. So on number 4, if, and now what am I going to do with this next part? Underline the hypothesis. So if, and then I underline. Okay? By the way, these were P and Q up here. Just that first part, right? You can scratch out the other part. And then the conclusion is after the then, right? So after then, I'm going to circle what? They never intersect, okay? Now, everyone, look closely. This can, if I give you a page of just if-thens, this would be really easy, right? Sometimes they switch it around on you. Does everyone look at number 5? 5, the if is not at the beginning, right? Right, so it's going to, after the if, what do I have to do over here? Underline after the if. So do you see? Sometimes they switch it around on you. So you got to look for the word if, and then underline after that. Okay? So the first part is going to be my conclusion, which is Q, and the last part is my hypothesis, which is P. Okay? So again, it can be tricky. Just look for the if and underline after if. Circle the other part. Cool? So could you do that on an assignment tomorrow? Okay? Now, bottom part. Here's a statement, okay? You want to tell me if it's true or false. Do we all know what a linear pair is? 2 angles that make a straight line next to each other, right? And then, do we all know what supplementary means? Supplementary is when 2 angles add up to what? Supplementary is what? When they add up to what? 180, okay? So let's answer this question. Looking up here. If 2 angles form a linear pair, then they are supplementary. Is that true? So again, linear pair make a straight line. Straight line is how many degrees? 180. So that means it's supplementary. This is true. Okay? So if it's a linear pair, it is supplementary. Cool? So that one's true at the bottom. Right? 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 There you go. All right, now flip it over. Okay, now, for the rest of this, okay, now, some people say, Mr. G, you're boring, and you're dumb, and you smell bad, all right? Well, that's mean. But, for real, sometimes, you know, I don't do cute things in this class, but today, we're going to get real cute, okay? Because I'm going to be wearing this arrow. Okay? Cool? Actually, let me show you. For my video, okay? Check it out. Big facts. Wearing the arrow. All right? Now, here's the deal. For this, I'm going to show y'all some hand signals for this so you can remember this stuff. We're going to learn converse, inverse, and contrapositive, okay? So, let's read this. Converse is a statement formed by interchanging the hypothesis and the conclusion of a conditional statement. Now, if you read that and you understood it, that's great. But if you didn't, I'm going to make it memorable, okay? So, notice how it says P arrow Q becomes Q arrow P. What happened with P and Q? Switched, right? So here's how we remember this. It's called a converse. When you hear the word converse, what do you think of? The brand of shoes, right? Hey, there's some right there. Who else? Who else? Who else? All right, you're an all-star. Get it? Converse all-star? Okay, cool. Now, imagine you were going to tie your shoes, okay? And you grab those laces. What do you got to do with those laces? You cross them over, all right? Don't you cross them over as you lace them up, right? So, let me show you what I mean here. When you are talking about, and by the way, check out, I got cool stuff, right? So I'm going to start off with P and Q. Wait, where's that? There you go. All right, P arrow Q. This is a conditional statement. So what do I do with the converse? I switch them. So now it's Q arrow P. Can't really see it. Q arrow P. Okay? So again, P and Q, switch spots. Here we go. Switch spots. Question. Just switch the order. Okay? So check it out. I want you to think of tying your shoes. So I want everyone to do this with me. I need audience participation. Take your hands and show me your palms like this. Whoop. Now, what do you do for Converse? Whoop. Switch them. Okay? Like you're tying some shoes. Tie those shoes. Tie those shoes. Okay? So again, Converse is switching like you tie your shoes, switching your hands. Okay? So let's write this down. My statement is at the top here, from the last page. It says, if two angles form a linear pair, that's the hypothesis, underline that. Then, what do I do with this part? Circle, then they are supplementary. That's my cue. Okay, so at the very top, everyone's underlining the hypothesis and circling the conclusion of P and Q. And now we're going to rewrite this sentence as a converse. What do I do with P and Q again? Switch it, like I'm tying some shoes. So I'm going to always start with if, and then I'm going to use the yes. If they are supplementary, that was right. I'm going to abbreviate, if they are sup. Then, and then I'm going to put the P at the end. Two angles form a linear pair. Okay, now, I'm kind of abbreviating, I'm kind of changing a few words to make it shorter. But does everyone see what I did? All I did was change the order. That's called a converse. Now, let me give you an example. You may not like it, but I'm always going to say it. If I'm Mr. G, then I'm cool. What's the converse of that? No. What do I take Mr. G and cool and switch them? So if I'm cool, then I'm Mr. G. Thank y'all. All right, but seriously, you can make up anything in the world. Okay, let's make it something that y'all may agree about. So if you're Lil Nas X, then y'all know who that is. Oh my gosh. All right, if you're Jay-Z, then you are a Rockefeller Records guy or something. Okay, if you're Jay-Z, then you're married to Beyonce. What's the converse? If you're married to Beyonce, then you're Jay-Z. I'm just saying, just take the sentence and flip it. That's all you got to do, okay? Cool. You could keep doing examples, but you get the idea. If you're the Cowboys, then you're the best team ever. I get it. Yeah, then if you're the best team ever, then you're the Cowboys. That's how it works, right? All right, that's the converse. Okay, now, real quick. Is this statement true on the board here? Is this one right here true? So if they are supplementary, then they are a linear pair. Now, what's the difference between supplementary and linear pair is that they can be disconnected, okay? So check it out. Here's an example. 30 and 150. Are those supplementary? What do they add up to? 180. So are those supplementary? Yes. So if they're supplementary, then they have to be a linear pair. But wait, this is not a linear pair because they're not next to each other. They're not, like, touching, right? That makes sense? Like, supplementary can be detached. Linear pair has to be attached. So this is false. Very good. So go on that box over there, put false. You can draw a little arrow and draw that little picture. Okay? That is my counterexample to that statement. You're telling me every supplementary is a linear pair? False. There is my counterexample. Okay? Please. So that is a converse. Cool. So again, P and Q, switcheroo. Is it true? Scooby-Doo. All right, so that's for converse. Now we're going to do inverse, okay? Inverse is a statement formed when both the hypothesis and conclusion of a conditional statement are negated. Now real quick, here's a vocab word. Is everyone looking up here? Negated. What do you think that means? What does it sound like? It sounds like negative, which is the opposite of positive, right? So negated really just means an opposite. So here's the statement. I'm Mr. G. What's the negated statement of I'm Mr. G? I'm not Mr. G. Okay? The easiest way to negate something is just to put a not in front of it. Okay? I'm the funniest teacher ever. What's the negation? I'm not the funniest teacher ever. Okay? I know y'all don't believe that. Okay? Now, negated comes from the word negation. A negation is just to say opposite. Okay? Some of y'all like to argue with your parents, maybe, or argue with your friends. You're always doing negations. You're always like, nuh-uh. Okay? Hey, quiet. So, write this down. Now, real quick, look at the symbols. See how P arrow Q is now squiggle P arrow squiggle Q. Now, there's a word for this squiggle, and it's a tilde or a tilde. Miss Murrow thinks it's tilde. Fine. So, but you know what? I don't mind if you call it a squiggle, but squiggle P, arrow, squiggle Q. Now, what does the squiggle mean? What do you think? Negation, right? All it means is not. Okay? Or opposite, or negation, whatever, okay? So I'm going to say not P implies not Q. So guess what I'm going to bring back? I'm bringing this back. All right, so I got P, arrow, Q. Let's recap. Converse was switching, right? Now, what do you think I'm going to do for inverse? So if you didn't notice, the back has negations. So everyone, look up here. Look. I did not switch the order. I just flipped them over to make it squiggle P, squiggle Q. So P and Q are in the same spot, just with the squiggle on top, or in front, okay? So I want you, show me the hands. This is not a stick up, this is math. Show me your hands, okay? So this is a conditional. What was converse? What do I do? Whoop. That was converse. Switch them, right? But what do I do for inverse? You're going to do like a fiesta wave. You're going to switch them over. Whoop. Or like you're doing like ba, ba. Okay? So all you do for inverse is switch the order. Flip them over to make them opposite. And y'all know the word inverse sounds like invert, kind of. That's all you're doing with your hands. Don't switch, just flip. Okay? So again, conditional, converse, and then inverse, opposites. Okay? So that's the hand signs. Let's do this. To write the inverse, we're going to do the opposite of P and the opposite of Q. So what's the opposite of P? Two angles form a linear pair. What's the negation of that? Real quick. What is the opposite of this statement right here in P? What word do I just have to add to it? Not. So instead of two angles form a linear pair, they do not form a linear pair, right? So I'm going to start writing it maybe a little differently. If it is not a linear pair, then what's the opposite of they are supplementary? They are not supplementary. Guys, for negations, just put not in there somewhere. It'll make it opposite. That's fine. Okay, write it down. If it is not a linear pair, then they are not supplementary. I may have my grammar a little bit off there, but all right. Again, if you don't have perfect sentences, as long as I can get what you're saying, I'm a little merciful. Miss Murrow wants me to be more merciful. So here's the question again. Is this true or is this false? Okay? Has everyone written that sentence down? Okay? So what do y'all think? If it's not a linear pair, does that mean it's not supplementary? Can you think of an example that's not a linear pair, like this up here? Okay? So look at this example up here with the 30 and 150. They're not touching, right? So that's not a linear pair. Does that mean it's not supplementary? Is this or is this not supplementary? It is though, right? So actually, that same example, actually this is false. I know it's kind of confusing, but this up here, the 30 and 150, is an example of not being a linear pair, but it is supplementary. So I know this kind of, I know. When you have extra knots and you're trying to think of if it's not true, it's a lot of knots, right? Ties you up in knots. All right. Well, anyways, now converse was switch, inverse was flip. What do you think we're going to do with contrapositive? Double, switch and flip. Okay, so check it out. Contrapositive says, a statement formed when the hypothesis and conclusion of a conditional statement are both reversed and negated. Reversed and negated. Okay? So real quick, let's talk about this. Okay? So again, I have if P, then Q, right? If P, then Q. So converse was switching, inverse was flipping, right? Now, for contrapositive, the way I remember that is it's a long word, so it's got more than one step, okay? The P and the Q are going to switch places, and they're going to flip over. So now it's not Q implies not P. Cool? So, let's see those hands. Let's see it, okay? Because this one is like a dance move. Y'all ready? So check it out. So, what was the first one called again? Before converse. The original is called starts with a C, conditional. The original is conditional. Now, converse, we do what? We tie our converse. We switch the order. What is inverse? What do I do with my hands? I invert them. Opposites. Now, contrapositive. This is like a dance. Y'all like dancing? Okay, ready? Here's what you're going to do. Switch and flip. 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 All right, so, again, and do it at homecoming, just say Mr. G taught it to you. You know, you're like, all right. All right, so, because math is groovy. Scooby-Doo. All right. Well, anyways. So, now, let's write this down. Now this can be kind of complicated. Take the P and the Q, switch it, and put not in it. Okay? So what's going to go first here? Okay? They are supplementary. Put a not in there. It's going to be they are not supplementary. Okay? Is everyone with me? Looking over here on the side, looking at the phone over here in the front. Okay? If they are not supplementary, then they are what? What's the P? They are not a linear pair. Okay? So again, everybody, P and Q switch places and with a not. Okay? So they are not supplementary, then they are not a linear pair. Two changes. You switch the order and you make them opposite. Whoops. Let me see if I messed this up. Dang it. All right, hold on. Now, is that true? Think about it. If two angles are not supplementary, they don't add up to 180, right? Supplementary adds up to 180. So if they're not supplementary, can they make a straight line? No, okay? So this is actually true. If they're not supplementary, they're not a linear pair. Go ahead and put true there, okay? So is everyone able to write these sentences? You're going to have to do it tomorrow. You're going to have to know converse is switching. Inverse is not switching, just opposite. The contrapositive is switch and opposite, okay? There's one last thing we got to note today. It's biconditional. Now, when both the original conditional statement and the converse are true, that's called a biconditional statement. Now, check it out. Don't blink. I got one new thing. Oh, whoops. My arrow turns into a double arrow, okay? So again, we got the double arrow for biconditional. Y'all know bi means two, and this is two ways that it's true, okay? The conditional is true, and the converse is true. I want everyone to look up here. We're almost done. Please. So, notice the symbol, P, double arrow, Q. When do I use a biconditional? When it's true both ways, okay? Now, this is very important. I want you to underline this, put a star next to it. If and only if, put a star right next to this thing. You've got to know this phrase. If you're doing a biconditional, you use the phrase if and only if. You don't use if, and you don't use then. So every other one uses if and then, right? This is the only one where there's no if and no then. What do you use instead? If and only if. I want everyone to say that. If and only if. Say it. If and only if. Good. Now, for example, we would say, look at this. Two angles are supplementary if and only if their measures sum up to 180. There's no if here. There's no then here. It's just if and only if in the middle. Okay? The last two things we're going to do is write a biconditional statement. So class, you tell me, on number one, do I write if? Let's cross that out. Am I going to use then? Let's cross that out. What do I put in the middle there? What do I put? If and only if. So let's write this. I'm going to start with this right here. An angle is acute. And then I put that phrase, if and only if. And then I put it measures less than 90. Degrees. Sorry, it's kind of messy. Now, that's a biconditional because it's true both ways. Aren't acute angles less than 90? Yes. Aren't less than 90 angles acute? Yes. If it's true both ways, you got the double arrow, and it's called a biconditional with if and only if. Last one, let's do it together. What do I write first? Do I write if? Okay, so today is Thursday. Okay. Do I write then? No then. Okay. If and only if. Whoops, kind of messy. If and only if. I don't write then, and I put tomorrow is Friday. True. So follow this. Today is Thursday if tomorrow is Friday. That's true. What about the other way? Tomorrow's Friday if today is Thursday. That's true. Okay? So it doesn't matter about any other day of the week. As long as it works both ways, it's if and only if biconditional. Cool? All right. I know that was a lot. Okay? But that's it for the notes, and then we're going to work on an assignment tomorrow.